Good morning. It is time to talk about the metric system and what the metric system involves. One of the part of the things that I want you to know in regards to the metric system is why do we need to know the metric system? Okay. One reason is because we are one of the only nations in the world. There are only 3 nations in the entire world that do not use the metric system. Everybody else in the entire world utilizes the metric system. That actually puts us as Americans actually behind the 8 ball in regards to business dealings with other countries. We need to utilize the metric system. And one of the college classes that I took a few years ago when I went to factories that made plastics, one of the factories we went to makes all the plastic bottles that we utilize around here, whether you drink water, whether you drink pop, whatever it is, they make the plastic bottles. And something that I found was very interesting was when I went into that factory, basically as soon as you went into the factory, everything was metrics. Okay? Instead of the English system that we are so used to, where you measure things in pounds and measure things in gallons. No, instead they use the metric system. So by understanding the metric system, that actually puts you ahead of everybody else that wants to get a job. Right? So it is important to make sure that you know it. Right? The other thing that we're going to find out later is that the metric system is so much easier to convert things from one thing to another. And my thing that I love to point out is that if we were at a football game and we said that Billy carried the ball 3.5 yards, and I want to know how many feet did he carry the football. So how do I figure that out? 3.5 yards. Well, first of all, you got to know there's 3 feet in a yard. So 3 yards times 3 feet, that would be 9 feet. And then he went another half a yard. Well, half of a yard would be 1.5 feet. So you'd have to go 9 plus 1.5 feet. That makes it, okay, he carried the ball 10.5 feet. And then if I said, well, how many inches did he carry it? Well, how many inches are in a foot? Well, there's 12. So you'd have to go 10 feet times, or 10.5 feet times 12 inches. So that goes, well, 10 times 12 is 120, and then half of 12 is 6. So it turns out he carries the ball 126 inches. Okay? Now, all that calculation was all math stuff. In regards to the metric system, all we have to do is take the decimal point, and we either jump the decimal point one direction or we jump the decimal point the other direction in order to change from one type of unit to another. There was a known case that occurred in a satellite where the 2 companies that were building the satellite weren't communicating, and one was communicating in one set of units, basically in English, and the other one was communicating in metrics. And when they built the satellite and it was sent off to, I believe if I remember right, it was sent off to Mars. When it got there and they activated the jetpacks in order to get it to land, because they hadn't been communicating in the same measurement units, they didn't work properly, and the satellite that they sent there crashed. And so this was a $1 billion project that crashed simply because the 2 companies were not communicating utilizing the same measurement. So it would be better if we all utilize this, because then that makes it so everybody's communicating the same language from no matter where you're at. And then also the idea is that us in America, we for some reason are unwilling to change to get used to this. And I hope to also, by the time we get done with these videos on the metric system, you'll see that you guys are already starting to change into the metric system, whether you want to or not. And what you find out is that the businesses are the ones that are pushing this to occur, which is perfectly fine. The reality is they're going to be the ones that are going to be more effective in getting all of us to change to the metric system. I, as a teacher, I can teach you how to do it, but I can't get you to change to use it. So by now you should have the notes all copied on the metric system, and you should have those in your notebook, so you should be able to follow along in your notebook as we go through these. So they should have looked something like this. That's what the notes looked like online. All right. So very beginning here, we got the standards. There's 3 different standards. There's the meter. The meter measures distance, measures from one place to another. All right. The liter is used to measure volume. You already do this because if you go and buy a bottle of pop, what do you usually buy it as? You usually buy it as a ½ liter, 2 liter bottle. A lot of it is sold in the metric system. And also, if you notice, like our canned foods, they also have it in milliliters down at the bottom of the can to tell you how much is inside the can. So we're already utilizing the liter system for our volume of a lot of the foods that we eat. The third one is the gram, and I put down there, which is exactly right. The gram is a measurement of mass. And what is mass? Mass is the amount of matter that's in an object. It is not weight. Weight instead is the pull of gravity. Okay? My weight right now, sitting here in front of you, is 240 pounds if I use the English system that we are really, really used to. Now, if I went outside, jumped into a spaceship, and flew up to the moon, and I took my weight on the moon, would it be the same? Nope, because the polar gravity on the moon is less. My weight on the moon would be about 40 pounds. Would I change at all? No, I would be exactly the same. All right, I still have exactly the same amount of stuff inside me, same amount of matter inside me, so my mass would still be the same. It would still be the 240 that I was here. But because the gravitational pull is so much less on the moon, because it's 1/6 the size of the Earth, then I would weigh 1/6 what I do here. So that's why instead of 240 divided by 6, I would weigh 40 pounds on the moon, even though I would look exactly the same as I do right here. So you got to remember that mass is not weight. Mass is the amount of matter. It's how much stuff you're made up of. Weight is the pull of gravity. Right, and I will tell you, you're probably going to see that question again down the road here, like coming up on a test that you're going to have to do. All right, so now we could take these measurements, and let's say that I wanted you to measure the distance from Madison School all the way to Blissfield School. Right, and I were to give you a meter stick. Right, and if I gave you a meter stick, which is about this long, and I wanted you to, gosh, I don't have one out here. Hold on one second. Let me go grab a meter stick. All right. So here's a meter stick. All right. Here's how long it is. Okay. On this meter stick, again, if I told you I wanted to measure the distance from here to Blissfield School, using this meter stick, oh my gosh, this would take forever. You'd sit there and go 1, 2, 3, 4, 5, and you'd be doing this for a long time trying to get all the way to Blissfield Schools. Okay. What could we do in order to make this a whole lot easier? Well, we can take this meter stick and we can tape a whole bunch of them together. Right. And what I can do first of all is I can tape 10 of these things together. If I tape 10 of them together, then I get a decameter, right? And you should find this in your notes, and I'm going to draw this a little bit at the back behind me, is that first of all, we have the standards, right? And the standards are meter, liter, gram. And that's what we just talked about a minute ago. And it depends on what you are measuring as to which one of those you use. If you went to a football game, you would not hear the announcer say that Billy carried the ball 7 liters, but liters, what are you talking about? That's like how we measure pop. That's not how far you carry a ball in football. No, you carry it blank meters down the field. Okay. Also, you wouldn't go to the gas station at Myers and go in and tell them, yeah, I'd like to get myself a 2-meter can of pop. They'd be like, meter? Well, we don't sell it in meters. We sell it in liters. You can get a 2-liter bottle of pop, but you can't get a 2-meter bottle of pop. So depending on which thing you're doing, distance, volume, or mass, determines which one of these standards you're using. So now we can make these things bigger. And that is I can make this and go 10 times, which would be deca, which is dk or dA, and that is 10 times. So that's 10 times bigger than the standard. So that's 10 of these guys taped together. Now if that's not big enough, which that would only be about the length of a school room at school, we got to go bigger. So let's go another 10 times and let's take 100 of these things and tape them together. Okay. If I tape those together, then I got a hectometer. That's 100 times. Okay. So that's 100 of these things taped together, which that would be like, gosh, like about the length of a football field, give or take a little bit. Okay. It's still kind of small. So let's go even bigger than that. Let's go to the next 0, which would be kilometer, which is 1,000 times. Now that would finally be enough of it. You take 1,000 of these things, put them together, and you can lay it out in front of the school, flip it over, bonk, and then flip it over again. And about the time you got to about 9 or 10 of them, you'd be to Blissfield schools. It would be about 10 kilometers away. Right? That would be a whole lot easier than 10,000 of those meter sticks going back and forth trying to get all the way to Blissfield schools to find out its measurement. Now we can go even higher than this, and this is when all of a sudden I'll point out that you've already done this before. And that is, at this point on my scale, you have to add in a couple blanks. These are not in your notes, you're gonna have to add these. But you go a couple blanks, and what those blanks are, those have a numerical or number value. And this one would be, if you notice, we're adding zeros. 10, add a 0, it becomes 100, add a 0, it becomes 1,000. So if we had a 0 here, it would be 10,000 times. This would be 100,000 times. Then we get to the next one, which is mega. And that's 1,000,000 times. Now, if you had an old iPod, right, like the first iPhone that was out there, or iPad that was out there, you'd say, well, it's got like 4 megabytes of memory. Now, if I said I was going to give you one of those, you'd probably be like, wow, yay, exciting. I can put like 2 songs on that, and that's it. I can't even play video games on it because it doesn't have enough memory in order to do that, because it's only got 4 megabytes. What do you actually want? You want something that got gigabytes, right? You want gigabytes so that you have more memory in order to put stuff on. Well, what's a gigabyte? Well, to do a gigabyte, we have to go, I'm going to stand up on this one, is we have to go 2 more blanks, so that's 10 million, 100 million, and we get to giga, and that's 1 billion times. Right? So that means we have a whole lot, and even your phone, if you were to check your phone's probably got like 4 gigabytes in it, and a gigabyte is a lot bigger than a megabyte. If you went to the phone place and they were like, yeah, we got this new phone right here, you want to buy this phone? It's got 4 megabytes of memory. You want to buy that? You want to buy it? You want to buy this phone? You'd be like, I don't want to buy it. It's only got megabytes of memory. I want one that's got gigabytes, so I get enough memory in order to store everything that I need. So we know that gigabytes are bigger than megabytes. And even if you went to the store and bought a brand new computer, you might even go, wait, I don't even want a gigabyte. I want to play video games. I want something even bigger than that. So I'm going to go even higher than that, and we're going to go blank, blank, and we're going to go tera. And that's 1 trillionth times. And that's even bigger. That's even got more memory to it, right? So we can go up like this, and reality is there's even more. You can go online and look it up and see. I mean, in reality, with this whole idea of the metric system, we just multiply by tens and or by thousands, and that's how we keep getting these things up. And that's why I have the blanks up there, is that because we're multiplying by thousands, so we got to include those mathematical values in between. All right, I'm almost to the end of my time that I can do on this, so I'm going to stop. This will be part number 1. Make sure you watch the second one. That's going to show us going the other direction, going down, and some other stuff about the metric system. So go to part 2 now. See ya.